Venice has survived wars, plagues, and more than 15 centuries of rising and falling tides, but today its greatest enemy arrives twice a day. Water. The city is built inside a shallow lagoon separated from the Adriatic Sea by a narrow chain of barrier islands. Most days the tide moves through 3 inlets, refreshes the lagoon, and leaves again. But when strong winds, low atmospheric pressure, and an unusually high tide combine, the Adriatic pushes into Venice faster than the lagoon can release it. The result is acqua alta, high water. In November 2019, the tide reached 1.87 meters. Around 80% of Venice flooded. Water filled shops, entered churches, damaged stone, and covered St. Mark's Square. The images looked almost unreal, but the solution Venice had been building was even stranger. 78 enormous steel gates hidden on the seabed. Together they form MOSE, one of the largest movable flood defense systems ever constructed. And when a dangerous tide approaches, the sea itself lifts the barriers into position. To understand why Venice needs this system, you first need to understand why the city is sinking. Venice was built on more than 100 small islands. Early builders drove millions of timber piles into soft lagoon sediment, then placed layers of stone and brick above them. Because the wood remained underwater and largely deprived of oxygen, it did not decay in the way exposed timber normally would. That foundation proved remarkably durable, but the ground beneath it is still slowly compacting. During the 20th century, groundwater extraction accelerated the subsidence. Pumping was later restricted, but Venice had already moved lower relative to the sea. At the same time, global sea level has been rising. These two effects combine into what matters locally, relative sea level rise. Even a small change makes flooding more frequent because many streets and squares sit only slightly above ordinary tides. St. Mark's Square, one of the lowest parts of the city, is often the first famous location to disappear beneath the water. For generations, Venice adapted with temporary walkways, waterproof barriers, raised pavements, and tidal forecasts. But exceptional floods demanded something far larger. The lagoon connects to the Adriatic through 3 openings: Lido, Malamocco, and Chioggia. Engineers realized that if these inlets could be temporarily closed, the dangerous surge could be stopped before it entered the lagoon. That sounds simple until you see the scale. MOSE uses 4 rows of gates across the 3 inlets. Lido is wide enough to require 2 separate rows. Altogether, the system has 78 gates extending across roughly 1.6 kilometers of water. Each gate is a hollow steel box about 20 meters wide. Depending on its location, a gate can be more than 20 meters long and several meters thick. Under normal conditions, it lies flat inside a concrete housing on the seabed filled with water. Ships pass above it, tides continue moving, and from the surface the barrier is almost invisible. When forecasts predict dangerous water levels, operators activate powerful compressors. Compressed air is pumped into each gate, forcing seawater out. As the gate becomes lighter than the water around it, buoyancy takes over. Still connected to the seabed by giant hinges, the gate rotates upward until part of it emerges above the surface. One gate rises, then another, then an entire row. In about 30 minutes, the separate steel boxes become a continuous barrier between the Adriatic and the lagoon. The sea can rise outside while the water level inside remains controlled. When the danger passes, the process reverses. Water is allowed back into the gates. They become heavier, rotate downward, and settle into their seabed housings again. Lowering them takes roughly 15 minutes. It is a remarkably elegant idea. Instead of building a permanent wall across a living lagoon, Venice creates a wall only when it is needed. But that flexibility comes with complications. The Venetian lagoon is not a swimming pool. It is a complex ecosystem that depends on the exchange of water, sediment, oxygen, and nutrients with the Adriatic. Closing the inlets for too long can disrupt that exchange. It can also interfere with shipping, fishing, and port operations. That is why MOSE is designed for temporary closures, usually lasting several hours rather than days. Navigation locks help some vessels continue moving, but every activation still has consequences. The gates also live in one of the harshest environments imaginable for machinery. Saltwater causes corrosion, sediment collects in housings, marine organisms attach to surfaces, hinges, seals, compressors, electrical systems, and control rooms all require inspection and maintenance. And there are 78 gates. Construction began in 2003, but the project suffered years of delays, cost increases, technical problems, and a major corruption scandal. Estimates vary with what is included, but the final cost climbed to several billion euros. For years, many Venetians wondered whether the system would ever work when the city truly needed it. Then, in October 2020, all 78 gates were raised against a forecast high tide. Outside the lagoon, the sea continued climbing. Inside Venice, St. Mark's Square remained largely dry. The hidden wall had worked. Since then, MOSE has repeatedly protected the city from tides that would previously have caused serious flooding. But success has created a new question: what happens as sea level continues to rise? The system was designed to protect Venice from very high tides, potentially up to around 3 meters. Yet its long-term challenge may not be a single extreme event. It may be frequency. If ordinary sea level rises, the gates will need to close more often. More closures mean more maintenance, greater disruption to the port, and less natural exchange between the lagoon and the Adriatic. A defense designed for emergencies could gradually become part of everyday life. That is why Venice cannot depend on MOSE alone. The city is also raising vulnerable pavements, improving drainage, protecting building entrances, restoring salt marshes, reinforcing shorelines, and studying how the lagoon itself can adapt. Engineers must protect the architecture without turning the lagoon into a sealed reservoir. So why not build one permanent dam and separate Venice from the sea forever? Because that would save the monuments by destroying the system that made the city possible. The lagoon is neither fully marine nor fully freshwater. Its channels, mudflats, and salt marshes are shaped by moving tides. Every day, seawater passes through the inlets, spreads across the shallow basin, and retreats again. That movement flushes pollutants, carries oxygen, redistributes sediment, and creates habitats for fish and birds. A permanent wall would also transform Venice's port. Commercial ships travel through the lagoon to reach terminals on the mainland. A fixed barrier would require enormous locks operating continuously, changing navigation and concentrating traffic through a few controlled openings. MOSE therefore works like an emergency door, not a new coastline. That distinction also explains why forecasting is so important. Operators must decide to raise the gates before the highest water arrives. They combine tide measurements with wind, atmospheric pressure, rainfall, river flow, and models of the Adriatic. Closing too late risks flooding. Closing unnecessarily creates costs and interrupts the lagoon. The system is not simply 78 pieces of steel. It is also a network of sensors, forecasts, control rooms, compressors, power systems, and people making time-sensitive decisions. And the gates do not always need to behave as one machine. Because individual barriers can be controlled separately, operators can respond differently depending on the forecast and conditions at each inlet. That flexibility is one of MOSE's greatest strengths. It is also why maintaining the system will remain a permanent engineering responsibility long after construction crews leave. Venice is often described as an impossible city. Its buildings stand on timber, its streets are canals, its foundations sit in mud. And now its survival depends partly on steel doors sleeping beneath the sea. MOSE does not permanently defeat the water, it buys time. Every time the gates rise, they hold back the Adriatic for a few critical hours. Those hours protect homes, churches, businesses, artworks, and one of the most extraordinary urban landscapes on Earth. But the final future of Venice will depend on what the world does with the time those gates provide. Because the most impressive thing about Venice's hidden wall is not that it can stop the sea, it is that eventually the sea is always allowed back in.